Hi guys, we're going to start off chapter 5 with a quick recap of all the GCSE knowledge that you need to have. If you understand all this, then the transition is going to be very smooth. If you don't, you're going to struggle big time. Now, it wasn't always a favourite of everyone's at GCSE, straight line graphs, so let's make sure you understand it now before you even start chapter 5. Okay, so if we ask to find an equation of a line, you need to understand that this is the general formula for the equation of a line, y equals mx plus c, with m being the gradient and c being the y-intercept. Now to find the gradient, lots of teachers do it different ways. This is probably my favourite, dy by dx, or people say changing y and use delta, and they do this. But the way we seem to tend to do it more often, and the good advantage about this one, if I can get my words out, is it tells you whether it's going to be positive or negative straight away. With this one, I just used to make a sketch with this, and it's easy to get at the gradient positive when it should be negative. But this one you're never going to make a mistake, and it's one we tend to use more at A level because there's other formulas that it will support easier. So this is the one we're going to go with for this video, just to make a bit more sense. So we're going to start by calling this x1 and y1 because it's purely the first coordinate, and this one x2 and y2. So m would be y2 take away y1, so the change in y, or the difference in y. So that's 7 take away 1, which is 6, divided by x2 take away x1, so change in x, or the difference in x, which is going to be 4 take away 2, which is 2, and therefore 3. So at this stage we know it's 3x, but we don't know what this is. Now you can do this just by looking at the coordinates. You know the y coordinate is 3 times the x coordinate and then something else. So 3 times the x coordinate is 6, so you've got to take away 5. 3 times the x coordinate is 12, so you have to take away 5 to get the y. So I can tell you straight away it's 3x take away 5. And how well you've been trained is your ability to do that. What most people do is they take a coordinate, it doesn't matter, let's take this one and pop it in. So y is 1 and x is 2, so you get 1 is equal to 6 plus c, and therefore c is equal to minus 5. It's just a much slower way of doing it, but it comes in handy. You must be able to substitute into a formula. Let's make it a little bit harder. Let's just drop this down a tad. Okay, let's make it something like this. So I'm just going to work this one out quick. Okay. Okay, so this one's a little bit more complicated. So m is the change in y, or y2 minus y1, divided by change in x, which is the same. So we're going to have minus 3 minus 3, so that's going to be minus 6. And we've got 8 minus 4, which is 12, because the double negative is a positive, which is also the same as minus a half. So at this stage we know y is equal to minus a half x, and then something else is happening. This one's definitely the easiest to do it with, so half of that is 4, so minus half is minus 4 plus 1. Let's check that out. Half of that is minus 2, so minus half is therefore 2, and add 1, it works. But just so you understand, I'm going to use this coordinate, I just like it better. Minus 3 equals, I'm just writing down what I just verbally said. So minus 3 is equal to minus 4 plus c, add 4 to both sides, you get that. So y is equal to minus a half x plus 1. And normally we like to write it this way around, just because we think it looks a bit prettier, I guess. Both of those are correct. So you need to know how to find equations of straight lines from coordinates. You also, if my computer hurries up, you need to know how to find perpendicular gradients and parallel gradients. So for example, if we have y equals 3x plus 5, a perpendicular means it goes at right angles. So you can see the steepness is not the same. It's actually reciprocated. So a perpendicular graph to this is when if you imagine this to be that's still the same thing, we reciprocate it, and of course we change its direction to make it meet at right angles. So that, I put an x in there, that is a perpendicular graph to this one. But the y-intercept doesn't actually matter, so you can change it to whatever you want. It's still going to be perpendicular because it's the steepness that makes it. So I could write, for example, that, or plus or minus c. Parallel graphs, if we start with the same one, whatever the steepness is, we need to match that steepness. So therefore, we just keep the gradient the same. And that can be a whole host of different y-intercepts. It doesn't matter. So the gradient, as long as that's the same, it create a parallel graph, and we reciprocate it, makes it perpendicular. We could make it a bit harder. Let's change colour. So if we made it like 5 minus 2/3 of x, for example, a perpendicular graph would be, I just put c because that's the bit that doesn't matter. We're going to change its direction to be a plus, and we're going to reciprocate to that. A parallel graph would be any y-intercept, just not 5. Well, it could be 5, that's on exactly the same spot. Just like 4, 2, it's easier to change it. And see the gradient is the same here and here. So that's parallel. We reciprocate it and change its direction, or negate it. It's another way of saying it. That's perpendicular, so that's perp, and that's the parallel one. Okay, the other thing you need to remember is this, and actually I personally didn't cover this very often because it's just simply rearranging. But so if we have this, we just rearrange it for this form. So there's a coefficient of A, there's a coefficient of B, and there's a coefficient of C. So everything needs to be on one side. So as the majority of it's on the right, let's just keep it there. So it'd be 2x minus a y plus 5. That's really it. However, this will be a little bit new to you possibly. Now, quite often they want these just to be whole numbers, like an integer, so its fraction isn't ideal. So let's get everything on the left. I know I said the opposite on the one before, but when there's a negative x, it's just easier to get rid of it. So if both the coefficients are positive of like the x and the y, it's definitely a bit easier. So let's put it in the front as well. So half x plus y minus 5 is equal to 0. So in this instance, what you want to try and think about is not having a fraction. So how would you get that to a whole number? There's a whole host of things you can do, but what we'll always do is the lowest like common multiple, if you like. So if we times this by 2, they would cancel out, and therefore you have 1, or half doubled is 1, so it'd be 1x. But if you times this by 2, you've got to times everything by 2. So what you're actually going to have is that, and it's just bad practice to do that. So it's just x plus 2y minus 10 equals 0. So that's actually something new. So it's not a GCSE recap. But if you're asked to write in this form, make sure your coefficients a, b, and c is not technically a coefficient, it's a constant, but make sure they're whole numbers. Okay, but this is a recap. It's probably not your favourite, but you want to write a perpendicular graph to this and that passes through here. So you can see this is written in this form. Oh, so by. So let's get it into our normal y equals mx plus c form. So let's have 3y. Let's keep that on the left, and we'll have 2 minus 6x. So if you divide everything by 3, we get 2/3 of minus 2x. You should be very comfortable following what I've just done there. Now, perpendicular means I don't really care about this y-intercept. I'm going to write it the other way around. I think you'll probably be happier. That is irrelevant at the moment. So a perpendicular gradient would be you negate it, so you change it to a positive, and you reciprocate this part. So that's going to be a half x plus c. So there it is. But now we've got to use this to make sure it goes through this point. So I'll just rewrite what I've got there. Oops. And we're trying to find c. So 1 is a half of minus 4 plus c. We don't know what that is yet. So that's minus 2, because half of 4 is 2. Add 2 to both sides, and we get this. So the perpendicular graph to this, and that passes through this coordinate, is y equals a half x plus 3. Now if they wanted it back in that original form, you'd have to put everything on one side. So, oh, what's happened there? Sorry. I'll just change colour for this bit. So we'd have y minus a half x minus 3 is 0. We'd have to times throughout by 2 to get rid of this denominator. So we'd have 2y minus an x minus 6. So that is the equation of the line that is perpendicular to this one and goes through that point. Okay, so that's your GCSE recap plus this little extra bit here, and now you are ready to start Chapter 5. There are actually, I must say, lots of exercises in which you can practice in Chapter 5 this, but it is technically GCSE.